Okay, so in last lecture, we have discussed about the smoothing special domain filters, or you can say low pass special domain filters. Okay, today we will talk about the sharpening special filters, that is high pass filter. Okay, now in this the three types of special high pass filters are used. First one is a first order derivative, the filter which is based on the first order derivative. Then second one is a Laplacian operator, or you can say a second order derivative. And third one is a high boost filter or unsharp masking filter. Okay, now in last lecture we have discussed about that first order derivative filter. Okay, uh, df upon dx is equal to f of x plus y minus f of x. So this is the one dimensional function, is one dimensional difference function for the special domain high pass filter. Okay, now we will discuss about the next, that is the second order derivative, or you can say Laplacian operator. Okay, now what is function of this, or what are the necessary condition for this Laplacian operator filter? So it must be zero in constant areas, right? Then it must not be zero at one end and other end of the intensity ramp, and it must be zero along entire ramp. Okay, so these are the what we can say some necessary condition to design the Laplacian operator filter or second order derivative filter. So actually it is a linear operator that is used for the image sharpening. Okay, and the Laplacian of a two-dimensional image f of x at any location x comma y is the second order derivative, and it is defined as the del difference square f upon dou square x square is equal to f of x plus 1 comma y plus f of x minus 1 comma y minus twice f of x comma y. So this is the equation for the second two-dimensional image f of x comma y at any location x comma y. Okay, it can be expressed in other ways. Del del square f is equal to d square f upon dx square plus d square f upon dx square d square y, right? So you have learned about the second order derivative, the same function we are using here. Now what is difference between this first order derivative and this Laplacian operator, that means second order derivative? So in case of first order derivative, it is implemented using gradient operator. Okay, this first order derivative, it is implemented using gradient operator, while second order derivative, or you can say Laplace operator, so as the name indicates, it is used or it is implemented by using Laplacian operator, right? So first order derivative produces the thicker edges in an image. If you use the first order derivative filter, then the output will be the image which contains the edges much thicker than the original one. In case of second order derivative filter, it produces very fine and thin edges in an image. Response is stronger to the line than to a point in case of first order, right? In case of first order, response is stronger to the line than to a point, right? In case of second order, exactly reverse is the case. Response is stronger to the point than the line. Okay, and the last difference about between this first order and second order derivative, in case of first order derivative, it has a less ability to enhance fine details in an image, while in case of second order, it has a better ability to enhance the fine details in an image. That means in a bottom line, you can say the second order derivative or Laplacian operator filters are gives always better performance as compared to the first order derivative, because first order derivative which produces the very thick line. Okay, the edges are represented by very thick part, whereas the second order derivative, the edges or the edge part is nothing but very fine and thinner. Okay, म्हणजे जे एज म्हणजे काय, टू regions madla boundary, two regions madli separation boundary. Okay, so this particular edges is nothing but in case of first order derivative, this edge can be represented very thick line. In case of second order derivative or Laplacian operator filter, this edge can be represented at very fine and thin line. बरोबर आहे. म्हणजे फर्स्ट ऑर्डर डेरिव्हेटिव्ह मध्ये थिकर लाईन अँड सेकंड ऑर्डर डेरिव्हेटिव्ह मध्ये थिनर लाईन. सो दिस इज द मेजर डिफरन्स बिटवीन द first order derivative and Laplacian operator or second order derivative. Okay, now the last is again third type is high boost filter. Okay, so actually this type of filter is not there in your syllabus, but still we will discuss something about it. So this high boost filter on this unsharp masking filter, it is actually what you can say is nothing but the original image minus low pass filtered image, right? This high boost filtering operation means what? From the original image you have to difference the image which is produced by the low pass filtering, and that difference is nothing but high boost filtering. बरोबर आहे. म्हणजे हाय बूस्ट फिल्टरिंग म्हणजे काय? ओरिजिनल इमेज मायनस लो पास फिल्टर्ड इमेज या दोन्हीचा डिफरन्स, बरोबर, ते म्हणजे हाय बूस्ट फिल्टरिंग, राईट? You have to take the original image and you have to difference the response which is generated by the low pass filtering of that same image. Then after taking the difference, whatever the output you will get, that is nothing but the high boost filtering. Okay, suppose that original image, right, is equal to 1, then we have a simple high pass filtered image, because 1 minus low pass filtering is nothing but high pass filter, right? So original image is as equivalent to the one that high boost filter will behave as a high pass filter. But if that a, that means original image coefficient, is greater than 1, then it will behave as a high boost filter or unsharp masking. Okay, so the high boost filtering actually it is a modified version of the high pass filtering. Okay, so actually it is just a little bit modified version of the high pass filtering. Okay, so this is about the what you can say image sharpening in spatial domain or high pass filtering in spatial domain. Okay, so these points are there in your syllabus. So today we have finished with this unit number 3, that is image enhancement. From next lecture we will start with the unit number 4, that is image segmentation and morphology. Okay, so these are the points that we have covered in this unit. Okay, and this is the last point, that is the image sharpening in frequency domain. Okay, so if you have any doubt regarding this unit, you can ask me right now, or else I will declare the unit is finished. कुणाला काही शंका आहे का? Everyone through with this unit?